Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Syafami bin Manazri. Today our group will present about Torricelli'S theorem, and I will present for my part, which is abstract, objective, and interaction. So for abstract, this experiment is conducted is to correlate or to determine the Torricelli relationship between the velocity measured value and the velocity theoretical value. Uh, so that to conduct the experiment, we have some apparatus that we need. The first one is a cylindrical tank with hole, measuring tape, and clay marker. And also in this experiment, we use water as the fluid. In this experiment, we have some manipulated variable that we use that we have. The first one is height, which is the uh, the the distance between the hole of cylinder tank and the floor. And another one is the volume of water. So for the height, which is distance between drill hole and floor, is the first one is 36.65 cm, second 56.5 cm, the last one is 76.15 cm. While for the volume water, we have five volume. First one 2 liter, 1.5, 1.75, 1.5 liter, 1.25 liter, and last one 1 liter. Time taken for water to dispense and the point where the first water droplet fall is marked by using clay marker, and the horizontal displacement is measured and recorded. To get the accuracy result in this experiment, we have to repeat this experiment at least 3 times to get or to acquire the average value. Uh, the average value. As for the objective, the duty of the experiment is to determine Torricelli relationship by comparing measure and theoretical value of velocity. Evangelista Torricelli, for introduction, Evangelista Torricelli is Italian physician and mathematician, which he is the one who discovered this Torricelli law of Torricelli theorem. Torricelli's law is a theorem in fluid dynamics concerning the speed of the fluid flowing out of an opening, or what we call orifice, and the relation of the height, which is the between hole and the floor of the fluid above an opening. This theorem is important, which it contribute to contribution lead to a new light of discovery and invention. Evangelista Torricelli invented in some of the first one that he invented is mercury barometer in 1643. He also known for his work, which is in optic and fluid dynamics. He also found that water leaks of a small hole in the bottom of a container at the rate proportional to the square root of the depth of the water. For the Torricelli equation, this equation is derived from the Bernoulli equation. So that's all for me. Thank you.
Assalamualaikum and good morning. My name is Haris Iqbal bin Hisham. So today I want to present theory and methodology. So for the theory, if you have fluid stands at the depth of H in an open tank whose side walls are vertical with a hole is made in one of the walls, the velocity of a non-viscous fluid flowing from a cylindrical tank can be represented by Torricelli'S theorem. So the equation is V equal to square root of 2gh, where V is the velocity, h is the depth below the surface of the liquid, and g is the gravity of fluid. Next, the velocity of the fluid coming out of the spout is the same as the velocity of a single droplet of fluid that falls from the height of the surface of the fluid in the container. Water stream from the hole is in a horizontal direction, which can be represented by kinematic equation. So for this case, the velocity v at any point I can be represented by the time taken t. by the stream to cover a horizontal displacement of water stream, the x of the water stream x. So for this equation is x is the distance of water stream equal to vi times t. So for constant acceleration, the equation is in below. So for x naught is the time when it's 0, and xi is the time when it's I. So this dx is represented by displacement of water stream, where a always equal to 9.8. So for methodology, this is the apparatus that we use to do this experiment. So for the first step, the apparatus was set up based on the different height of stages, where there are 3 different height of stages. Next, the cylinder tank was placed at H1, and the cylinder tank was filled up by water. Next, the hole at the cylinder tank was covered to stop the flow of water at desired volume, and finger was taken off from the hole. And at the same time, the maximum distance was marked using the clay, and the time taken was recorded. And for the last step, experiment was repeated by using different volume of water at different height of stages, H2 and H3. That's all. Thank you.
Assalamualaikum. My name is Shafiq, and I will be present the results, discussion and conclusion. Table 1. The result obtained for height from floor to orifice is 36.65 cm. This is table 2. The result obtained for height from floor to orifice is 56.55 cm. Table 3. The result obtained for height from floor to orifice is 76.15 cm. Discussion. Explains your selection on dependent, independent and constant variables. Dependent variables: maximum water trajectory distance, time taken for water to drain out. Independent variables: height from floor to orifice, volume of water. Constant variables: density of water, diameter of the orifice and cylindrical tank, gravitational acceleration. The choice of the variable is to fulfill the objective, which is to verify Torricelli's relationship by comparing measure and theoretical value of velocity. This will be finally separated into two parts, which is the effect of initial water level on the water velocity and effect of height from floor to orifice on the speed of water. Clarify on how you can relate the Bernoulli equation with Torricelli's law for this case. Show all the derivation and explain each step. Torricelli's law may be derived from Bernoulli principle and relative the velocity of fluid leaving an orifice in a fluid-filled container to the height of the fluid above the orifice. Torricelli's law is derived from Bernoulli equation by equating the potential energy in the static head of liquid to the kinetic energy of the water leaving through the orifice as follows: P1 per rho g plus V1 squared per 2g plus Z1 equal to P2 per rho g plus V2 squared per 2g plus Z2. The P1 and P2 is 0 since it is at atmospheric pressure. V1 is considered 0 since the movement of fluid is so small and almost to 0 due to that point as datum. And we get this equation: 0 per rho g plus 0 per 2g plus Z1 equal to 0 per rho g plus V2 squared per 2g plus 0. We get Z1 equal to V2 squared per 2g. Subsequently, rearranging for velocity, we get the Torricelli's law: V2 equal to square root 2gz1. Percentage of relative error for the theoretical and measure values. We will use this equation. To find percentage error, P modulus V theoretical minus V measure per V theoretical times 100. To find average percentage error, sum percentage error per 5. To find V theoretical, we use square root 2gh, and to find V measured, x times square root g per 2y. For right equal to 36.65 cm, we get the average percentage error, which is 29.26%. For right equal to 56.5 cm, we get the average percentage error, which is 26.66%. And for the y equal to 76.15 cm, we get the average percentage error, which is 45.66%. Source of error and method to minimize the errors. Parallax error due to the position of the ice, which is not perpendicular to the scale of measurement. Leakage occur at the cylinder around the orifice. Inconsistent when using stopwatch, especially when starting or stopping the stopwatch. Method to minimize the error. Ensure the eye level is perpendicular to the scale when taking reading. Ensure that all the leakage are well covered. Repeat the experiment a few times to get the average reading. Conclusion. To conclude, we were able to verify Torricelli's law relationship by comparing measure and theoretical value of velocity. From the experiment, the percentage error are relatively high due to several errors that occur during conducting the experiment. Thus, some recommendations should be taken to overcome the errors to get the better result of an experiment. Thank you.